Welcome to Study Loop.
All right, guys, we're going to be doing problem 44 in chapter 5 in chemistry, the central science. So we're going to look at the following equation. We have it right here, where methanol is being converted into methane and oxygen. Now, part A, we're asking if this reaction is exothermic or endothermic. Since we have delta H is greater than 0, it's by definition endothermic. If delta H is less than 0, then it's exothermic. So we're going to calculate the amount of heat transferred when 24 grams of methanol is composed by this reaction. So we have to change this equation. We have to act like we're using one mole of methanol produces 1 mole of methane and half a mole of oxygen. This is going to change this from 126.4 kilojoules to 126.4 kilojoules per mole. So per mole of methane we use, this is how much energy we're producing. So to do this, we have to convert this into moles. 24 grams over 32 grams per mole. So that's going to give us 0.75 moles. Now we're going to multiply 0.75 times 126.4, and that's going to give the moles cancel out, and that's going to give us 94.8 kilojoules. And in this case, the amount of heat transferred is equal to the enthalpy. Q is equal to delta H. So that means that this is the value of our Q, the amount of heat that's transferred. Now, for section C, we're going to ask, they're looking at seeing the delta H for this transition for a given sample of methanol is 82.1 kilojoules. So how many grams of methane gas are produced? So the way we figure this out is we know how many kilojoules are produced per mole. So by using this, we can find out how many moles we have. So do 82.1 kilojoules over 126.4 kilojoules per mole. So 82.1 divided by 126.4. That's going to be 0.65 moles. All right, now we're going to convert that 0.65 moles into grams. So we're going to multiply this by the molecular weight of our methanol. Our methane. So 16 grams per mole. And that's going to give us 10.4 grams. kilograms of methane are produced given a sample that produces this much energy. Now, for part D, how many kilojoules of heat are released when 30.5 grams of methane reacts completely with O2 to form methanol. So we're actually going to have to flip this equation, because we're not using methanol to produce through CH. We're not using methanol through CH4 and oxygen. We're reacting methane and oxygen to produce through CH3. Now to start off, we're going to have to flip that. So we have negative 126.4 kilojoules per mole. So we're going to convert us. Now we're going to convert our mass into moles. Moles convert. So that's going to produce 2.4 or moles. So then we're going to multiply negative 126, x.4, 2.4, and we get at negative 3 is negative 300. .4 kilojoules. And since, remember, delta H is equal to Q, that's Q. So we're releasing a magnitude. So when we're talking about heat, they're talking about amount of heat released. So we're dealing with it in terms of magnitude. So in this case, delta H is going to be equal to negative Q. Negative delta H is going to be equal to Q. Because if negative amount of heat is released, then that means that you're absorbing heat. So the magnitude of Q is going to be a 303.4 kilojoules. So you should think about the wording of the question when you're answering it, because that can affect the sign of your answer.